Welcome to my YouTube channel with videos. Today we're going to be looking at the paint release shader. More specifically, Gabriel de Labier's stylized paint shader breakdown. Now you may be asking yourself, what is a paint release shader? Well, this is a toon shader. Very helpful, I know. They're just constant color values, stepped up and down, depending on normals and light direction. A paint release shader is just a distorted version of that. Pay attention to the textures they use, similar to paint strokes. Did I make what you're looking at right now? No. Gabriel de Labier did. But I did make this, however. Just hold on a second though. Gabriel de Labier's tutorial omits a lot of details, and I've seen a lot of people struggle to pick up on those details, so I'm making this video in order to help guide people. If you want to save yourself the pain of recreating this shader from scratch, you can check out this YouTube series linked in the description. The person who goes through it is very thorough, and it even includes a GitHub of the completed project. But it's not a one-to-one of Gabriel de Labier, so I want to go over the exact techniques that he uses. Okay, so the first thing that Gabriel de Labier does is creates a 4-channel image, 2 of which red and green are for mobile channel. The diffuse is blue, and the alpha is used for a transitionary texture, which is this one. If you were to do this in Photoshop, I cannot tell you how to do that. It is simple if you just right click. Now, go to channel signal at the bottom here, you can add an alpha channel, and then you can just control V this whatever texture you want, but you are not able to do that with the other textures. I thought if I just took this and I just changed the hue to blue, it would allow me to input it on top of these others, but as it turns out, it just turns the other channels to black. So I opted for, the better option of all, and is just to upload the images one by one unpacked, which makes more draw calls for images, and I not start doing that. If you can find a way to pack it, then you should probably do that. But back to Unreal Engine here. After he creates this image, first thing he does is creates a simple. He starts with the toon diffuse, but it's unlit. So in mine, here's what my nodes look like. Because I'm using an unpacked texture, this is RGB, but normally it would be alpha for a packed texture. And this is RGB, it would normally be blue, goes to the height bump offset, 0.1. Make sure to copy these nodes to 2 colors. When you look at this is the lit model, I think. Should be, yeah. And as you can see, there's a bit of parallax going on here. Get this on the big screen here. Very interesting stuff. Something also to watch out for. When you're making this model, you're probably going to want to change this to blending mode to masked. And I never figured this out, but yeah. Just change the blending mode to mask. That's probably what you're going to want. Material domain surface, yeah, that's probably all fine. And then when you go over here, this is reconstructing world space normal, and all of these nodes. And one of the issues that forums had, that I want to go over here, is approx world space normal. You may be wondering why I can do this and you cannot. This is a named reroute node. You can add a named reroute declaration node, and this basically, I feel like stuff is over here. Anyway, that basically allows you to put another version of this node that takes the same input data somewhere else. So this may travel this way, but it can also, I can add another node here. It's the exact same thing as taking this and just putting it right over here. But it's more for making things as neat as possible. Moving on. Next thing he does, hits it reflection data. These nodes make up reflection, swizzle, RNG. As I said, my nodes were unpacked. This normal map uses RG and B data, but the B data doesn't exist. I guess not. A normal map normally consists of all 3 channels, RG and B, but he said that he was able to pack it into two, since typically, if you look at the blue channel of most normal maps, they're pretty much just nothing. And this technique covers the ability to use two channels for a normal map, and that is what these nodes are doing over here. This part, it's kind of just reconstructing the blue node, the blue channel, without using it. It's so that you can use two channels instead of three, which allows more space to pack in more textures. Something else I want to make note here is transform vector. Make sure that you're selecting the right one, because it would be from something to something, tangent space or world space. This one's tangent space or world space, but this one, which we'll get to later on, is something else. It's local space or world space. So just be careful for stuff like that. So as we move on here, we're now on to SDF occlusion, which is something I never got to work myself. As you see in this image, it's kind of like ambient occlusion, where it kind of shows the shadows of intersecting objects, which I am not too sure about myself. It looks like in order to get this to work, both of the objects use SDF fields, sign distance fields, because it doesn't just work with nothing, because at the end of this, you can see that the corners of this object are affected, or at least distance field approximately. Also, he never shows step scale, but I'm just going to assume it's a default, otherwise these are all the same nodes. But ambient occlusion shows it intersecting with another object, but it doesn't bleed onto the other object like it does in his examples, where it actually bleeds onto that plane. So I'm assuming that he created that plane with the same material, and they just bleed onto each other. So if we were to go into here, with these two materials, it's kind of hard to tell, but if I were to distance, like, these two objects are kind of bleeding onto each other here. It's kind of, since my materials are all messed up, it's kind of hard to tell, but I should be, if it works, it doesn't really touch the ground at all, right? Even though this is actually touching the ground, it doesn't bleed onto it. So if I had to guess, in order to achieve this effect, you can't just, both of them have to have SCS occlusion accounted for. Both of the shaders have to have material accounted for. Moving on now, Fresnel is simply, the more parallel something is to the viewer, the lighter it is. So imagine like a piece of cloth. The pieces that are most parallel to the viewer are the lightest. And we're simply using that to say this object is near the edge, like it's near the silhouette of the object, so we want to erode it. We want to create this erosion that looks like paint strokes. So the drawback of this is hard surfaces. So something like this, if you were to angle it such in a way that it is close to parallel to the object, you're going to get this entire surface just gone. This entire thing will just be eroded, which is bad. It doesn't show it here, but it'll look like a can instead of a cylinder, like a hollow cylinder instead of an actual cylinder with the top, which is something that we don't want. In order to combat this, he implemented a curvature filter, which are these nodes. Which, how do you do that, you may ask? You go to the content drawer, right click, add a material function, just click that, and then name it the curvature function. And these are the nodes that you use. Five zeros. Oh, cool. Where is this used? This is used, just making sure you have all of this. SDF occlusion, I never got this to work, but in case you're curious. Yeah, this is rim erosion. So if you do copy these notes, you're probably going to notice that this stuff doesn't work, and it will not work if you're just using the cylinder too. It's probably going to look really bad. Yeah, it looks so much worse than the other one. Wait. Huh. Yeah, opacity doesn't work on custom objects. What does this do exactly? So, his solution to this entire thing was don't use hard surfaces like the cylinder I just showed you. So what he did was in Blender, this is what it'll look like at the end, but you take a mesh, add a cylinder, whatever you want. You don't have to do this part, but this is what he did. Control R, size it up like I said. What I'm doing here is adding some extra geometry. What does this do? Well, it'll be more clear in a second, but it kind of creates, like this right here, it kind of creates like a better rim to use as opposed to just shading smooth. So after you created that extra geometry, W, shade smooth, go into this, color attributes, add a new color attribute, add, go into here, make sure it's cycles, bake normal, positive X minus Y plus Z to active color attribute, bake. And you'll know it will work. Wait, also W, shade auto smooth. You know it will work if you go into vertex paint and you see this stuff. This is a discrepancy that I had with this tutorial. Do you see how smooth this entire thing is? If I go to Unreal Engine, this data should not be like this. It makes me think that it's part of the reason why my shader is failing. He has said in the tutorial something, you probably don't have to bake it. You can optionally go into here, and instead of active color attribute, you can go to image texture and create an image texture and import that in, and instead of using this stuff, you can just use the image texture of an object space normal map. I haven't done that, but I think I might try it just to see if I can get the shader completely working. Anyway, vertex color normal, I've already told you this, it's just a rewrite node, and you can just add it, vertex. Once you've created it, you can just create it again. Erosion, all of this stuff should be the same. Like I said, local space to world space, make sure you have that. In the end, it will look like this. Hopefully it'll look better than mine, but, you know, like I don't know why it does this. Like, this is like, yeah. Anyway, so in order for him to achieve an outer rim effect and two outlines, he instances the object. In order to do this, in Unreal Engine, content drawer, add a blueprint class and an actor class. Once you create it, name it blueprint instances or whatever, add, or you can be in viewport. You won't see all this stuff. It'll be in viewport, and this won't be here. And you can add instance static mesh. This is one of the drawbacks of the mesh, of the shader. It doesn't like sharp edges, and meshes can only be static, which means it can't be deforming like a character, so it's in static mesh. I chose the test cylinder and I chose the test material, which is the material I'm working on, and you get this. In the construction script, this is what my nodes look like. If you were to recreate mine, click on Instant Static Mesh. Now, yeah, click on Instant Static Mesh and scroll down to Advanced Number Custom Data Floats. Change that to 1. It's because these custom data values have indexes. They're always at 0, but it kind of expects a place to put all this information. Otherwise, you're just throwing it into nothing. And also this set value is a discrepancy from Gabriel de Labier, which makes us assume it's something external, and I'm missing something, but where is it? Right here. Yeah. Otherwise, it's a one-to-one match. Moving on. Something I would like to point out is that you could probably recreate this shader with a deformed mesh using most of this stuff. You just wouldn't be able to instance the mesh because that would require it to be static. So if you were to go to UE5 inverse hull and follow a tutorial like this, you could probably get something similar to an outline. This kind of has the anime style outline, but you could probably distort this in a separate pass instead of using an outline, because the outline is kind of similar, except it just inflates it. That is a drawback of this, though. Inflating any object with hard surfaces, it doesn't really know where to put the normals, so it'll create a bunch of uneven space, which is bad. Because when we're inflating the mesh to create an inverse rim erosion, we're going to get artifacts. We don't want that. Another discrepancy between the video tutorial that I recommended and Gabriel the Labier is Labier. Inverse rim erode. This entire process creates a black outline, and this process, whatever erode, creates a white outline. The entire objective there is to create a white outline, and this one is to create a black outline. That is a discrepancy you'll find between the two of them. My reverse rim erode wasn't turning out too well, if you couldn't tell already, but this is what I came up with. This multiply wasn't there, and probably something else that wasn't there too. This used to be 0.284, now it's 0.01, and this goes into nothing, so you don't have to copy that. And this used to be 2, but it's 5 now. And next is outline opacity. This is to create an outline, but it's also to inflate the mesh. It doesn't show it here though. Mine doesn't look as good as this, but oh yeah, something about SDF. SDF goes to specular. Saturate, goes to loop, goes to specular, and I can prove it. If we go over to SDF, SDF occlusion saturate goes to 2 different places. We know that, and we know that in this image in the scriptures, SDF occlusion goes to that stuff, and then it goes to over here, in between, goes in between this one and this one, and we know from this video that there is a metallic and a roughness. There's a roughness and there's a metallic, and there's also a global static switch parameter used distance field AO. I'm really not sure how to create that, but I do have a feeling it might be this. This is a custom, this is a parameter, and this is a red node. I don't know where this goes, but it looks like it goes into a lerp node, so maybe it's something with that. But if we do look at this person's tutorial, it's interesting to see that they have stuff. If we look at this person's video, we do see that this person doesn't even use specular, so this person's tutorial doesn't even use SDF occlusion. They gave up on that entirely. Moving on, after outline, outline opacity, camera vector, LDAT, local space to world space. Yeah. For some reason, when I was connecting and disconnecting stuff, the 1 minus X, or sometimes the rim would be black, sometimes it would be white, so just watch out for that, I guess. Maybe it could happen to you. Shadow pass opacity is where things get interesting. All of this stuff, this wasn't working for me, so I added these nodes in between. Maybe you could try this, maybe not. It might just confuse you. If you packed it, use the alpha. 3-way lerp. We've seen this used twice. Once here, once over. Is that the first instance? Right here. 3-way lerp here, and 3-way lerp again. He has never shown us the custom function of 3-way lerp, so I did create an Unreal Engine forum. and asking for three-way lerp, and someone was nice enough to respond. Thank you, IllSpiritX. That it's an RGB mask to add brush strokes to lerp its feeding function of the texture. No way to know unless you see what's inside the function, so it's really just a guess, but my best guess is three-way lerp. It's this. And this input means nothing, so this is the input, right? And if you check use preview as default, then it'll use this texture if no input is given. And these are the nodes, just mask and then RGB individually and then max that. Anyway, these are reversed from Gabriel de Labier's video, so watch out. And this, I'm pretty sure, is to offset the two outlines, and it's not being used right now because I think I put it in the wrong space, but I don't think he plugged it into substairs. I think he plugged it. I think he plugged it into world position offset. I think that's what he did. Which makes me believe, wait a second. Yeah, it's not into substrate, into world position offset. Yeah. I'm pretty sure this is to make sure it's on index 2. That's, yeah. So, after he shows us the final bits of it, he just says that the rest of it's just mixed with simple lerps, and he does not show us any of it, which is unfortunate, but here's what I came up with. So after that, three-way lerp, 0 alpha, this was shown, I think, and the B is at 0, which is what I just assumed for all of this. This 1 minus x, I don't remember if it wasn't working or not. Oh yeah, because right now it's black on the inside, right? And we want, this is just a rim road. So we really just want the opposite of this. We want the center to be visible. So 1 minus x, lerp, three-way lerp. I think this one's also confirmed. I'm not sure. Shadow pass opacity. This may or may not be here. These two are guaranteed though, this one. That one is guaranteed. Over here, I don't know what's going on here. According to him, there's a constant and a red node that goes out of that. I'm not sure where he's getting that from, because if you change this, I don't really know. Oh wait, change this to 1, then it, yeah, I don't know. I'm lost. So maybe it's not a lerp. I don't know what node it would be though. I'm really unsure. Something that's interesting though, shadow pass switch. If you have, so in order to get these really cool shadows that these swimming shadows, like this shadow is not indicative of this shape, but you also want to keep the shape, is a shadow pass switch. So you have one mask with shadow and one mask for what you see. So this is what you see of my model. And this is what you'll see of the shadow. This is the shadow that's being cast. And notice how it makes sense, because you wouldn't really see the shadow moving around when you're doing this, right? So if we go here, you know how you can see the entire top here, but you can't see it over there? That's the shadow pass switch. Back to the test material. We don't know what this is. I gave my best attempt here, but I really don't know. That is shadow pass switch, though, I'm pretty sure. And SD occlusion, you mix that in with the tune. And then this, I have an idea of what it is. So this is my best attempt. I really don't know, though. Oh, cool. Yeah, it could be either one of these or maybe neither. Who knows? But this is wrong. And I'm confident of that. Because when you go to this video, and you go to, look at this, diffuse going into lerp, going into outline color, going into MF switch by instance data, going into persistent custom data. So what this does is it basically sets which shell are you using. So as it is a well-known fact of my model that this model does not work in the sense that this instant static mesh, if I go to this member and try to transform it, we can see that it's the exact same thing. And this is index 3. This should be like the outline or something. It shouldn't be that. Which means I have no mechanism to switch between the models, which means that this is probably this. So, closing notes. I'd also make sure for the SDF occlusion, we really don't know, but I would go into project settings and just double check that in rendering you have distance. Yeah, cool. That you have generate mesh distance fields checked. Otherwise, the part that I couldn't get to work will probably not work for you. This stuff, also this is probably, whenever there's an input node connected to this blue node, it's probably not three-way lerp. It's actually probably this node, like I was showing you, MF switch by data. It's probably something like that, but MF switch by data, that's a custom material function. MF material function. You will be able to find it on my GitHub that I talked about previously. So that's probably that. So is that. And we've seen all that. The only really unknown here is like this stuff. And maybe this too. Because I kind of messed up on that. If we're being honest, I have a feeling that this isn't what it's supposed to look like. I mean, maybe it is, but yeah. This could also be the this stuff that I talked about earlier not working. Because does it connect there somehow? Yeah. No. I don't know. It kind of looks like that map, so maybe it is, maybe it isn't. And this doesn't do anything either. Yeah, cool. Which is kind of why it goes nowhere. One other thing I'd like to note is that this tutorial, which is referenced on this video, uses what looks like deformed meshes, and it uses shells, and to my knowledge, it looks like adding more shells. Yeah, it's like adding, it's adding instant static meshes, I think, which makes me think that, I think they said in this video series that you have to use static meshes, but it's weird seeing this deformed mesh with shells. Makes me think that you can use deformed meshes with it, but I haven't really tried that yet. So anyway, good luck with anything, and hopefully this tutorial helped understanding this stuff. Hopefully you should probably check the description of this video to see if I completed the shader. I would like to upload a completed version if I can.